Drawing the system riser. From the Pipe Drawing Routine toolbar, select Draw Main Pipe. This command draws an AutoCAD line in the Pipe MN layer. For the first end, pick a point in a blank area of the drawing screen as shown. Move the mouse downward and enter 21 feet at the command line. Press Enter again to exit the command. This vertical line will become a section view of the system riser. Repeat the Draw Main Pipe command and draw two short horizontal pipe stubs at the top and the bottom of the riser pipe. Select the Etc. symbol from the Pipe Miscellaneous Pipe pull-down menu and insert the symbol on the ends of the pipes as shown. The Etc. symbols are to be used in section views only. They are not to be used in the plan view or errors may occur. When used in section views, Etc. symbols indicate to the program that the sharp pipe stubs are to be disregarded for hydraulic calculations and stock listing. You now have to connect the section view to the rest of the system so that it will be considered for hydraulic and stock list calculations. From the SprintCAD Pro toolbar, select 3D Routines. From this toolbar, select Insert Common Connection. Pick the center of the riser symbol at the end of the feed main. Press Enter to accept the rotation angle. The Edit Attributes dialog box will appear. Press OK to accept the A reference letter. The circle letter A will appear by the riser symbol. Common connection points allow you to jump from one part of the drawing to another. This one will be used to jump to the riser section. Select Insert Section Reference from the toolbar. Pick the end of the riser pipe inserted earlier. Press Enter 3 times to accept the scale factors and rotation angle. The Edit Attributes dialog box will appear. Press OK to accept the letter A as the section reference. The common connection point and the section reference must have the same letter. The section reference will be inserted. From the Pipe pull-down menu, select Draw Underground Pipe. This command will draw a line in the Pipe UG layer. Pipes drawn on this layer will be considered for hydraulic calculations, but not for stock lists. For the first point, pick the end point of the feed main. Make sure that ortho is on. Move the mouse downward and enter 18 feet at the command line. Move the mouse to the right and enter 18 feet. Press Enter to exit the command. Use the Move command to move the riser symbol from the common connection point to the end of the underground pipe. From the Pipe pull-down menu, select Miscellaneous Pipe, Pipe Rise. Insert the Pipe Rise symbol at the end of the feed main where the riser symbol used to be. Pick the pipe close to the break. This is also the location of the common connection point. Press Enter to exit the command. The Pipe Rise symbol will be inserted. Now you can enter fittings and valves in the riser section. From the Pipe pull-down menu, select Miscellaneous Pipe, Coupling at Break. You'll be prompted to enter the distance from the end of the pipe to the fitting. Enter 5 feet. Pick the bottom of the riser section pipe to insert the coupling. The coupling represents the stub up for the underground pipe. It will be 1 foot above the finished floor elevation. You will now install butterfly and alarm valves on the riser. Since there are pipe size changes from the underground to the riser and from the riser to the cross main, it is best to break the pipes for the valve insertions. Insert another coupling with the Coupling at Break command 3 feet above the last coupling. Then insert another coupling with the Coupling at Break command 7.25 inches above the last coupling. This is the sum of the takeouts for the two valves. When inserted, they'll be connected together with no pipe between them. Inserting couplings in this manner is just a quick method for placing pipe breaks for the valve insertions. You can use the AutoCAD break command or any other command that will produce pipe breaks for you. Now erase the last two couplings. Leave the short pipe piece between them. From the Pipe, Valves, and Plan menu, select Butterfly. Note the wide variety of valves that are available in the menu. Insert the valve with the end O-snap at the first breakpoint above the coupling. Pick on the Butterfly label, right-click, and select Properties to open the Properties palette. Change the valve size value to 4. Next, from the Pipe, Valves, and Plan menu, select Alarm. Insert the valve with the end O-snap at the breakpoint above the Butterfly valve. Pick the valve labels to turn on the grips. Use the grips to move the labels so that they're not cluttered as shown here. Finally, pick the pipe below the coupling and the short stub piece and change the layer to Pipe UG. This is the underground pipe layer. Pipes in this layer are considered for hydraulic calculations but not for stock listing. Elevating the pipes. From the Pipe Drawing Routines toolbar, select Multiple Pipe Elevations. The command line will prompt you to enter the elevation. Enter 19 feet. This is the elevation of the branch lines. With a crossing window, select the last branch line pipes along the top. Press Enter to execute. The elevation symbols will be inserted. Start the command again and elevate the branch lines below the cross main. Avoid the feed main. It'll be a different elevation. Start the command again and enter 17 feet as the elevation. Place 3 elevations on the cross main and 1 on the feed main as shown. Make sure to pick the pipes for insertions. If the elevation symbols are not inserted precisely on a pipe, errors will result. You can edit the elevation values by double-clicking on the tag. Start the command again and enter -4 feet as the elevation. Place elevation symbols on each of the 2 underground pipe pieces. The total elevation difference from the feed main at 17 feet and the underground at -4 feet is 21 feet. This is why the riser section was drawn 21 feet long. The length of the riser must match the elevation difference in the plan view. From the Pipe Drawing Routines toolbar, select Size Pipe by Schedule. With a window, select all the main and branch line pipes in the plan view. Do not pick the underground pipe, the system riser, or the riser section. Also, do not select the feed main or the cross main pieces that are shown in red here. Press Enter. The pipe sizing dialog box will appear. The branch lines will be sized by the criteria in the table. For 1 and 2 downstream heads, the pipe will be 1, Schedule 40. For 3 downstream pipes, the pipe will be 1 1/4, Schedule 40. For 4 and 5 downstream heads, the pipe will be 1 1/2, Schedule 40, and so on. The main size is set to 3, Schedule 10. The riser nipples are 2, Schedule 40. Check the riser nipple and riser nipple leader boxes to include these. Press OK to execute. the pipes will be sized. Start the command again and pick the 3 red pipes that were shown in the previous figure. Press OK when the pipe sizing dialog box appears to insert the sizes. Now you can size the underground pipe. From the toolbar, select Multiple Pipe Size. You'll be prompted for the size. Enter 6 at the command line. You'll be prompted for the schedule. Enter ductile iron. Pick the 2 underground pipes and press Enter to insert the sizes. Now you can size the riser section. Use Multiple Pipe Size to size the pipes. In this system, the pipe above the alarm valve and the pipe above the stub are 4-inch Schedule 10. The vertical piece below the stub up is 6-inch ductile iron, which is the same as the underground in the plan view. Do not size the short stub pieces at the top and the bottom. You can now display pipe links. From the SpringCAD Pro toolbar, select Update Drawing Pipe Information. The Pipe Information dialog box will appear. Check Center, Center, and press OK. The pipe links will be inserted. Inserting a 3D block is a great way to check your system for errors. When the command is executed, SpringCAD checks a number of drawing items such as elevations and pipe connections. If errors exist, a message box will appear identifying the problems. From the 3D Routines toolbar, select Insert 3D Block. Pick a point in a blank area of the screen. You can then move your mouse around to rotate the block. Pick again to insert the block. You can zoom in on the block to observe details of the system, including head orientation and pipe placement.